In this video of Let's Talk Math, we're going to learn how to solve a system of linear equations by using elimination. Now, there are steps to use elimination. First step is the equations has to be in standard form. Now, let's review on what standard form is. Standard form is ax plus by equals c. Now, sometimes it may not always be exactly like this. Sometimes it may look like this. By plus ax equals c. But they are still the same and will equal the same thing whether or not it is like this or like this. Now, let's go back to the steps. So the next step, one of the variables coefficient has to be the same as the one in the other equation, but with the opposite sign. Now, sometimes they might not always be true, so you can multiply the equations if needed to make this happen. Now, after this is done, add the left side with the left side of the equations and the right side with the right side. Solve for the variables left, substitute the variable in one of the equations, and solve for the remaining variable. Then you will have your answer. Now let's do a problem. Now, as you see here, both of the equations are already in standard form. And both x's, right, have 1 as the coefficient, but one is negative and one is positive. So now we need to add the equations together. Now to add equations together, right, we're going to add the right side with the right side and the left side with the left side, right? So this would become, right, y plus 2y minus x plus x equals 9. 6 plus 3. Now this will become 0. So all we are left with is y plus 2y, and that would equal 3y equals 6 plus 3, 9. So, if you wanted to, let's say, speed up the process instead of just writing it all like this, you could see which has a minus and which has a plus and then the same variable, right? Which this is. So this would be canceled out, and you just add this two together and then these together. If you didn't want to have to write the whole equation out. Now, let's divide both sides by 3. So 3y over 3 equals 9 over 3. This could be cancelled out, right? So y equals 9 divided by 3, which is 3. Now, the next step would be substituting, where we take the answer we have found, right, and put it in one of the y's. I'm going to do the top y. So this would become 3, let's do this, 3 minus x equals 6. Now, this would be the same as negative x plus 3. Now, we need to take away 3 on both sides, so minus 3 equals 6 minus 3. This becomes canceled out, right? That means negative x equals 3. Divide both sides by negative 1. X equals negative 3. So the answer is negative 3. Now that we have solved this problem, let's do another example. So now we have a system of linear equations that are both in standard form. Y plus 2x equals negative 3, and negative 2y plus 2x equals negative 6. Now both of these equations has a coefficient, right? 2 of the same variable that are both have this same coefficient, 2 and 2, right? But except they're both positive. So what we're gonna do is to make this not true, we're gonna multiply the equation, one of the equations by negative. I'm gonna do it by the top equation. So this would become negative y, right? So this would become negative y minus 2x, which would equal 3. Now we can add the top and bottom equations together. Negative 2y with negative y would become negative 3y, and negative 6 plus 3, right, would equal negative 3. Divide both sides by negative 3, it would become y equals 1. Then now we substitute. Now, instead of substituting with this equation, I'm going to rather do it here, right? So, the original top equation, so that would be 1 plus 2x equals negative 3. Subtract both sides by 1, so that would be 2x plus 1 minus 1 equals negative 3 minus 1. This becomes 0. 2x equals negative 4. Divide both sides by 2. X equals negative 2. So the answer for this problem is negative 2, 1. Now for our last problem, we have negative 3y plus 4x equals 2 and 2y plus 5x equals 14. These equations are already both in standard form. But we see here none of the coefficients are the same. Not even if they have the same sign. You have negative 3, 2, and 4, 5. So what we're going to do is instead we can multiply the equations if needed. So I'll have to multiply the top equation by 2, so this becomes negative 6. And I'm going to multiply the bottom equation by 3, so this should become 6. Now we're just going to have to solve. So negative 3y plus 4x would become negative 6y plus 8x equals 4, right? And the bottom equation would become 6y plus 15x equals 42. Now this will become 0 when we combine, right? And 8x plus 15x would become 23x, and then that would equal 4 plus 42, which equals 46. Now divide both sides by 23. X would equal 2. So now I'm going to substitute it in this equation. So that would be negative 3y plus 4 times 2, which would equal 2. And that would become, 8. So negative 3y plus 8 minus 8 equals 2 minus 8. That means negative 3y equals negative 6. Divide both sides by negative 3y and 3y would equal 2. So the answer for this problem is 2, 2. Now that we saw this problem, let's review what did we learn today. We learned to solve a system of linear equations by elimination. Write both equations in standard form. Then make one of the variables coefficient opposite of the same variable's coefficient in the other equation. Add the left side with the left side of the equations and the right side with the right side. Then solve for the remaining variable. Then substitute the solution in one of the equations. That is all for this video, so please put in the comments below what else you'd like to learn and like this video. I'll also be posting more videos with system of linear equations, so make sure you subscribe to my channel and check my other videos out. Bye!